Good morning, everybody. So today's lesson is to be able to multiply decimal numbers by 10, 100, and 1,000. We've done this before with whole numbers, and I'm sure that you will all remember what to do. When we multiply by 10, each one of our digits moves one space to the left. When you multiply by 100, each digit moves two spaces to the left. And when you multiply by 1,000, each digit moves three spaces to the left. Okay, it's really important when we're dealing with decimal numbers that we don't just say we add a zero, because we don't. The digits actually have to move. So if you have 4.2 multiplied by 10, we have a place value chart here, 4.2. Now if I said, oh, you just add a zero, it would still be 4.2. Adding a zero has not multiplied this by 10. Okay, so that's when I always say that is not a rule. Okay, so 4.2 multiplied by 10, each digit moves one space to the left. So our 4 moves into the tens, and our 10th digit moves into the ones. So our answer will be 42. Okay, again, if you think about the other day, it doesn't matter what side the calculation is on. The equal side just means that it has to be balanced. Both sides need to be the same. So 10 times 8.7, we're multiplying by 10. Each digit moves one place to the left. The 8 moves from the ones to the tens, and the tenths move into the ones. So our answer is 87. Okay, so just to repeat that, 10 times 5.43. 5.43, each digit moves one place to the left when we multiply by 10. So our answer would be 54.3. Okay, and for this one, again, it doesn't matter that it's this side of the equal sign. 10 times 35.07, each digit multiplying by 10 moves one place to the left. So our answer would be 350.7. 350.7 equals 10 multiplied by 5.07. James says when multiplying by 10, all the digits move right one place. Do you agree? I hope that you would all say no. Okay, if they moved right, the numbers would be getting smaller and you'd be dividing. Okay, when we multiply, we know our numbers get bigger, so they move to the left. Okay, not the right. Okay, so pause here and complete questions 1 and 2 on Seesaw. Okay, for the next few questions, we're multiplying by 100. When we multiply by 100, each digit moves two places to the left. So we've got 3.24 here. So the 3's in the 1's, it's going to move 2 places to the left. So it's going to move into the hundreds. Your tenths are going to move to the tens. And your hundredths are going to move to the ones. So your answer there is 324. Okay, again, doesn't matter which side of the equal sign the calculation is on, as long as they're both balanced. 100 times 2.3, so the 2 moves 2 spaces to the left, and the tenths move 2 spaces to the left. Okay, I can't leave it like this. I have to put a 0 here as a place value holder. So our answer there is 230. Okay, so just to practice those, 100 times 5.03, 1, 2, my 5 will move to the hundreds, my 0 will move to my tens, and my hundredths will move to my ones. So that would be 503. And 100 times 45.6, 1, 2, the tens will become thousands, 1, 2, the ones become hundreds, the 6 becomes a 10, and I have to put a 0 in here as a place value holder. Okay, so James says we're multiplying by 100. Some digits move left 2 places. Do you agree? Well, no, I don't agree, because it's not some digits. All the digits will move 2 places to the left. Okay, pause the video here and complete questions 3 and 4 on Seesaw. Okay, so this one, it says figure out what the missing factors are below. Okay, so what are our missing factors? So 5 something times 5.5 equals 55. So we had 5.5. You can use your place value chart to help you. I think you've got one on Seesaw as well. 5.5. Okay, and it's ended up being 55. So how did it get to 55? Each digit has moved one place to the left, so that must be multiplying by 10. Okay, let's look at this one. 40.62 equals something multiplied by 4.062. Okay, so let me just erase these ones. Okay, so we've got 40.62 and 4.062 is multiplied by something. So let's put 4.062 here. Okay, decimal point there. And we've got to 40, so that's moved to there, 40. So each digit has moved one place to the left. Therefore, it must have been multiplied by 10. Whoops. So you can use your place value chart on Seesaw to help you work out these missing factor questions. A bicycle is a word problem here. A bicycle is 1.7 meters long. A bowling lane is 10 times longer than the bicycle, so it's 10 times longer. A cruise ship is 100 times longer than the bicycle. So how long is the bowling lane? So it's 10 times longer than the bicycle. It was 1.7. 1.7 times by 10. Okay, each digit moves one place to the left, so it must be 17 meters. Remember to put the unit of measurement in. Okay, how much longer is a cruise ship than a bowling lane? So first of all, 2 steps here. How long is a cruise ship? Well, it's 100 times longer than the bicycle. So it was 1.7, and you've got 100 times bigger, so each digit would move 2 places. So it would be 170 meters. And the bowling lane, we know, is 17 meters. So we have to work out the difference between those two. So 170, take away 10. It's 160, take away the 7. We'd be left with 153 meters. Make sure you read those questions carefully. It's not asking how long a cruise ship is. It says how much longer. So you've got 2 steps on that one. Okay, so that's the end of this video. You can complete the rest of the questions on Seesaw.